Hello, and I'd like to do a problem from chapter 14. This is problem number 3. And it says a waiter believes that the distribution of his tips has a model that is slightly skewed to the left. So there's a little more on the right side. So it might be something like, kind of like that. With a mean of $9.10 and a standard deviation of 590. So that's my little sigma here, $5.90. He usually waits on about 40 parties. So that's my sample size. N is 40 over a weekend of work. All right, so the first question says, estimate the probability that he will earn at least $400. So if we look at the mean, the average per person, remember this is per person, the average that he would earn would be $9.10. And if he has 40 people, I'm just going to multiply that on my calculator real quick. That is $364, and that'd be on the weekend. On average, right? On average. Okay, so 400, since the mean and the standard deviation are both per person, I want to convert this $400 to be per person, and that nicely divides evenly. 400 divided by 40 would mean that, so 400 divided by 40 people, that would be $10 per person, right? So we want to find the probability $10 or more, at least, right? At least would be, they get at least $10 per person or more, so we're shading to the right. Now we can do this using the z-score, but since we have StatCrunch at our disposal, it would be a lot easier just to go ahead and type in these numbers. So 910 is our mean, $10 is our is going to be our value, our y value. And the only thing we have to adjust is this standard deviation, because this is for the skewed model. In order to use it for what's called our sampling distribution, our sampling distribution is related to the normal model, and we want our average to still be at $9.10. But because this is a different model than the original one, we have to use our little adjustment formula, the standard deviation of y bar is equal to the original standard deviation divided by the square root of n, and you'll learn that from the book and the homework. So that is $5.90 divided by the square root of 40. So let me do that calculation real quick. The square root of 40, that is equal to $5.90 divided by, I'll go to 4 decimal places here, 6.32, 4, and it's 5.5. So I'll just do the 5.5. I'll go to 5 decimal places. And what I get when I divide those two numbers is 2, 4, 5, 0.93. And what does it say? Round to 4 decimals. So we'll keep it 0.9328. That's for the standard deviation. We're not done yet. So here we have the standard deviation of y bar is 0.9328. All right, so we'll punch those numbers into StatCrunch. So let me just write them down so I don't forget. So it's $9.10 on average with the standard deviation of 0.9328. 1.328. So that's like $1, right? Difference per person on average. Some people tip $1 more, some tip $1 less. And then I want to find my Y value. What's the probability that I get $10 or more per person? So let's jump over to StatCrunch. For the mean, I know it's kind of small to see here. Maybe if I zoom in, you can see it. That mean is $9.10. The standard deviation is the one I just calculated, 0.9328. And then the probability, we're going to change that to be greater than or equal to. And then this is going to be $10, right? 10. Hit compute, and the graph should look like the one I drew. And it looks like we get a probability of 0.1673. So let's go back to the problem and see how we can use that value. So the question says, the probability that the tips from the 40 parties is greater than $400, and that would be the probability that we just got, which is 0.1673. That'd be the same thing as getting $10 or more per person. So that's the answer for part A. For part B, do this in a different color. The total amount he earns on the best 5% of such weekends. Best 5%. So we have our normal model here. I'll use the same one. So let's shade over here to the right. This would be the 5% region. And we want to find total amount that he earns on the, what is the amount? So how much is it going to be per person? So we're looking for this Y value here. We have the mean, we have the standard deviation, and we have our percentage. Using StatCrunch, we can calculate what Y is. And since 5% is less, right, our answer to part A was 16%. If you converted it to a percentage, we know that the answer is going to be bigger than $10. So it's less likely they're going to get this tip. So let's go ahead and punch those numbers into StatCrunch, and we can get our answer right from there. Our mean doesn't change. Our standard deviation doesn't change. The probability that I earn more than what dollars, I don't know. But luckily, I can type in the probability right here on the right, and that's going to be 5% or 0.05. Hit compute, and my answer should show up. Oh, it's not that much more. It's $10.63. So if you look at the graph, it's not significantly more than $10, but I guess that little bit makes a difference. So that is $10.63. That is the answer for part B. All right, thanks for watching. Hope it helped. And before you stop watching this video, I made a mistake as I checked the answer to this. It really isn't a big deal, but it's the wrong answer. The total amount he earns on the best 5% of such weekends, hopefully he's going to get more than $10.63, right, for the whole weekend. So we're going to multiply this. We forgot to multiply it by 40 parties. So multiply that by 40. And if you do that, you get $425.20. So that is right there. That is the final answer. Thanks for watching.